Hola, buenos días a todos. Vamos a dar un par de minutos para que se conecte un poco más de personas. Gracias. Muy bien. Creo que podemos comenzar, Peter. I think we can start.
Okay.
Bienvenidos a todos. Muchas gracias por estar el día de hoy aquí. Welcome to everybody and thanks to be here today. El día de hoy vamos a tener la presentación del doctor Peter Meyer, quien es director comercial en MER para la plataforma de BSSN, titulada El manejo de datos y la automatización en los laboratorios del futuro. Today's presentation, we are going to have our guest speaker, Dr. Peter Meyer, who is the commercial director at Merck for the BSSN software, with the title Data Management and Automation in the Lab of the Future. Quisiéramos solicitarles que mantengan sus micrófonos apagados durante el tiempo de la presentación. Al final tendremos un espacio para preguntas y estaremos también en el stand durante el resto del evento atendiendo sus inquietudes. We kindly ask you to maintain your microphones in mute mode and silence mode. At the end of the presentation, we are going to have a short time for questions, and we are also available in the booth in the event for any additional questions you have. Así que muchas gracias nuevamente a todos. Esperamos que esta presentación sea de su agrado y muchas gracias, Dr. Peter, por acompañarnos. Thank you very much again to everybody to be with us today. And thank you very much, Dr. Peter. You can go ahead with your presentations.
Yeah, thank you much, Dagoberto, for the introduction. Today I want to guide you through my presentation that deals with data management and automation in the lab of the future. So as Dagoberto has pointed out already, we are part of Merck since a while. So basically since 1.5 years now, and we are very, very, very excited about to be a member of it. So if we talk about laboratory of the future, so we think that the main topic should be data accessibility, because data accessibility can act or enable a lot of different things. And we think the more accessible we make our data, the more it will be used in the end. Yeah, and I mean, what we are standing for is clearly that we are in for the data. And I think you will all agree on that the most important part of your daily work in laboratory is, in fact, data you are generating on your instruments. And we think that these data should be as accessible as possible. Why? There are several reasons for it. And one reason can be integration between systems. So if you want to integrate instruments directly into a LIMS or a ELN solution, so to avoid, manual errors from typos, etc., etc. If you want to save a lot of time, then the result should flow automatically into these systems. And if you need to comply to certain regulations, of course, it should be compliant to Alcoa principles. But it also enables collaboration with partners or data management according to FAIR principles, data analytics. This can be predictive analytics. Yeah, so if you go back in the history of your data, also if you want to apply artificial intelligence or machine learning algorithms. And in the end, also, if you want to retain data over a long period of time, so also then data must be accessible. And think about if you need to retain data over 30 or 35 years, there are certainly some bottlenecks to overcome. And I will come back to this later on. So if we think about data accessibility, yeah, so this means we need really accessing the data. And the story I want to talk about is not about lab efficiency or productivity. It's much more than this. So think about what you are doing every day in your laboratory. So this is more or less the traditional business process that is behind. So because we know that behind every scientific experiment, so every experiment you are doing, there is a trigger, and the trigger is a reason. Yeah, so a trigger question. And the question is, what do I need to make something happen in the end? Yeah, so if you want to release a batch, you need to have some results, let's say from HPLC or from GC or from whatever measurement technique. But in fact, you need the results for a certificate you need to ship along with what you sell into the market. Yeah, and we do everything in the end to optimize the process of execution in order to make it happen. Yeah, and this is what we do since the early beginning. So since the time of where we go to kindergarten to school, yeah. So every time there's a trigger question, and we do our best to make it happen. But in the end, so if we go back then to laboratories, we lose a lot of information, because if we are only interested in the results, we lose the information about the raw data, we lose the information about metadata, and these data can add value today to what we name the data-enabled business processes. Yeah, and we need to realize even that we do not have all the questions yet in mind we want to address to our data. But I mean, if we in the future want to, dig very deep into data to get the answer on certain questions, the requirement is that they are very, very accessible. Yeah, and we can even think about that we can learn from what we are doing. And this is why today we capture as much as we can, so raw data, metadata, and results during the processes, during all the experiment execution. Yeah, and in the end, we can aggregate enough so we can trace things back according to FAIR data principles. And this is the reason why we use open standard solutions that are available on the market. And I will go into this topic now, talking about the techniques. So first at all, there is a data format, an open standard data format that is called Animal. So this is an open XML format for analytical and biological data. So this format, Animal, as said, is an XML format. And this one has been developed by a consortium from industry, from academia, vendors, and government entities in the early 2000s. So, and what is behind this data standard format is accurate and a complete representation of the original raw data set. Yeah, so there is a core that offers a very generic container format for any type of analytical or biological data. And on top, we always have a technical definition, and the technical definition knows exactly how to present data according to the measurement technique that is behind. Yeah, so it knows that UV-Vis data should be presented differently to MS data or NMR. Yeah, so this is basically the story behind, and the overall story behind Animal is that if we go with samples in the laboratory, we have our instructions, our SOP to prepare the sample, and then we do the experiment. And the experiment might generate also what we call daughter samples, yeah, and these ones you also investigate. Doing different experiments and also results. And these results not only consist of numbers, yeah, so the peak result table, but also of raw data, so the signal, and a lot of metadata that are connected to the instrument, to the method, etc. you have used. So in fact, really an accurate and complete copy of the original raw data set. So just to give you a short overview for what Animal stands in the end. So it's an open format, it's an XML representation for analytical biological data. It supports data from multiple analytical techniques, and you can even combine them. Yeah, so you can mix mass spec data with GC data, so with UV-Vis data, with Raman data. So if you concentrate on one sample in your laboratory and you investigate the sample using different measurement techniques, you can move all the different results into one Animal representation and review this independently of the original software in our viewer component. So with Animal, it's possible to capture sample and process data, not only results. Yeah, so if you have to comply to certain regulations, it's ready. Yeah, so it brings with it audit trails, digital signatures, and of course you can validate it very easily. And Animal is really the only data standard on the market that has a clear focus on data accessibility and ease of adoption. Yeah, because the story behind is the more easy a standard can be used, in the end, the more it will be used. And if we look around, you know, for data consumers like LIMS or ELN solutions, at least 50 or 60%, if we look on the suppliers of these informatics solutions, already understand and support Animal. Also, we need to have in mind that a standard only makes sense in the end if it is cheaper than the original software. Yeah? So if it is cheaper than to retain the original software over the next 20 or 25 years. Yeah, and we all know, I mean, in 25 years, nobody can even remember ChemStation anymore. And you will hardly find anybody that can control a computer where Windows XP is on. Yeah, so therefore we need those standards. So now I have talked about a standard for data, but if we need to integrate an instrument seamlessly into a LIMS or ELN solution, there is also another standard required that is doing the communication. Yeah, so that is doing the communication from LIMS to the instrument just to check the status of the instrument. And this is done by CELA. So this is a communication standard, and that is very important for the Lab of the Future initiative. So CELA, as said, is a communication protocol. So it's based on modern web technologies. It has standardized commands for common capabilities. And there is a very, very tight partnership with the animal for data. Yeah, so the combination, in fact, and now we are coming directly to the topic standard-based connectivity, is a very simple one. Yeah, so communication and data needs really each other. So if you want to integrate your data only into LIMS, yeah, then okay, you only need animal. But if you want to send the work list from LIMS to the instrument, then you also need CELA. So the communication protocol alone leaves us with the proprietary data structure. So in the end, yeah, so, and this has to be avoided, data ends up in a silo. Yeah, and also the file format alone is not very suitable for system where components need to communicate. And we all know that copying files is no communication. Yeah, so 20 years ago or so, but you can see it still today if you go to laboratories. So a text file maybe is saved on a disk and then copied manually onto another computer where the LIMS has access, and then the LIMS is extracting the results from the text file. But of course, nobody can know if there was a corruption of the file. So if somebody goes to the computer, does a modification of the text file, does a modification of the number, so it means of the results, this cannot be identified. And this is why today, if you go to pharmaceutical companies, if you go to chemical companies, to any type of laboratories, food, beverage, yeah. So if people want to increase efficiency and productivity, we need to understand that integration of an instrument into the leading system is what makes best sense if you want to be more efficient and to want to be more productive. And this is an example how it can look like if you are using CELA and animal in combination. So CELA is always talking actively to the instrument, which is shown here for a balance, but also on the right side for a chromatography data system. So CELA, in fact, can communicate with the device and gets back the information, can even visualize this inside the LIMS, but also is responsible for sending the commands for weighing, for weight to target, or opening and closing the door of the cabinet, which sits on the balance. And if the sample has been placed on the balance and the user is pressing the enter key, so the weighing result goes back automatically into the LIMS. And the same is true for chromatography data systems. So you can also nicely integrate them completely on a bidirectional way. So there also CELA is getting the device information, but it's also responsible for sample submission. So submission of the work list, and even we can generate inside any chromatography data system a sequence and execute it even independently of the user if needed. Yeah. And again, so same story. If the result is there, it was automatically back in animal, and people do not have to print out a report, go to the LIMS computer and key in the results again. So that is all completely automated. And with animal, we support a lot of techniques. It's not only chromatography, but also UV-Vis and mass spec, etc., etc. So a lot of different techniques that are supported. Yeah, so coming now to the second part of our journey, coming to data management. And if I talk about data management, so this means for us, it's vendor neutral, it's holistic, and it's in the cloud. So you don't have to care about the computer or server anymore, and you do not have to compare about IT department. So we take over all those services and sell or provide our solutions or as a service to you. So the first solution I'm going to talk about is a brand new solution that is called BSSN SciDiver. So what does this solution bring to you? So first of all, we have agents that are responsible for capturing data and converting them into the animal format. Yeah, so we have at the moment roughly 250 to 300 instrument models and data formats we are supporting. They are belonging to analytical chemistry, to biology, to physical measurement. So physical means like balances or pH meters, etc. Yeah, so all those measurement techniques are supported. And then we store data in a really massively scalable file store with central or distributed storage. And of course, we can offer this as a managed service to you. So either on-premise or hybrid solution. Yeah, so a lot of approaches are possible. But I mean, you do not have to care about. And the good thing is, then inside the solution, you can visualize raw data and metadata and also results from all these different measurement techniques independently of the original software. So you do not have to go back to the laboratory and ask people, okay, open this chromatogram, open this mass spec file, this Raman file. So everything you need to do is to log in and review all your results very transparently. And we have viewers not only in the cloud, but also you can review everything on mobile devices and even on the desktop. So there is also a desktop application that you can use for reviewing and processing of your data. And if I talk about processing, this means the process itself is completely decoupled from the vendor software. So as an example, we can do peak finding or integration independently. So you do not have to use the integration engine of your chromatography data system. And if you are using several of these chromatography data systems, you can move all the data very nicely into our solution, and then you can do peak identification or integration and then peak identification for all of them inside SciDiver. So this is basically what is behind this software. Just to give you an example how it can look like. So this is a chromatography data system from Chromeleon. So you see the chromatogram with baseline, so peak, start, and stop, and the compound is written on top of the peak. Of course, you have the peak table as well. So this is an example of Science Instruments Compass CDS overlay of 2 chromatograms. So an example of PerkinElmer UV WinLab in animal microplate assays in animal, Raman. So this is purification HPLC example, ECTA Unicorn. Also mass spectrometry is supported greatly. So an example here is Agilent MSD ChemStation, but we are of course also supporting Mass Hunter from Agilent, from SciEx Analyst, from Thermo, from Waters. Yeah, so there's a very nice coverage of these measurement techniques, and you can review everything, and it will look all the same. Yeah, so no difference as you have if you are natively using Analyst or ChemStation MSD. So you can review these measurement techniques very, very nicely and transparently inside SciDiver. So this is NMR, so another technique that is also nicely supported. And even you can bring bioreactor and in-process analytics into the same visualization. Yeah, so this is an example of Sartorius MFCS and from Roche SEDEX High-Res. And that is very interesting because this means we are supporting also instrument you are using in bioprocessing. Yeah. So if you are doing upstream or downstream experiments, we can move all those results you are gaining every day into the same animal representation and make it visible like this. So the next solution I want to talk about is called BSSN Hub. So BSSN Hub is what we call a holistic laboratory data management system. So it also starts with capturing and conversion of data files. It also stores very nicely these animal files in a file store. Yeah, and you can also navigate on, you can visualize on, you can process, you can analyze, and in the end, you can archive all your data. And how it really looks like, I will show you now. So think about the whole data processing pipeline. Yeah, so it starts usually always on left side, capturing of data, conversion of data. So there, again, we have animal converters for roughly 250, 300 different instruments and data formats. So we can bring all those analytical and biological data into one common format. Then we can integrate these results into LIMS, ELN, LES, or SAP for consumption. So these are the data consumers then. And therefore we have uni and bidirectional interfaces for communication, for data integration based on CELA and Animal. Yeah, so these two open standards that are available on the market. And then we can collect those data and give them, let's say, a central home. Yeah, and then we can apply metadata-driven navigation and queries because we can store all those data in the cloud and extract metadata from and can visualize then at next step these data vendor neutral and measurement independent, and we can process then raw data, metadata, and results. You can do this on Windows, on Mac computers, in the browser, and also on mobile devices. Yeah, and this allows you really that you can transparently review your data at any time, anywhere, and on any device. So next step would be if you need to share or exchange data with collaborators. And if I talk about collaborators, I mean with either internal or external partners. And external partners can be CROs or CMOs. And the benefit clearly here is that they can keep the same data quality as in-house. Yeah, so they can share data very transparently across companies, but they can use the same data lake as the other side, so the partner side. Then we can think about how can we consume those data that are in the data lake. So how can we reuse data? So for predictive analytics, for statistics, for data mining, for artificial intelligence and machine learning. And this is also greatly empowered by the fact that all those data are living in the same language. So the highly accessible XML format. And then if you need to plug third-party software that are doing the job for data mining, for example. Then we offer an API you can use to dive into the animal files and also into the metadata store, just to extract the data you are interested in, and then you can do fancy, you can apply your fancy algorithms and do the things you need to do. So the end game, usually if you go to QC laboratories, is always that they have to archive data over a long period of time. And of course, the request and the requirement is always that you can keep these data in an accessible and also human readable format. And so the whole data processing pipeline, as shown here, is basically covered by BSSN Hub as a cloud-based solution. So the journey, as I have pointed out already, is always starting on the data capture side. And if I talk about capturing data, I mean the raw data capturing as well as capturing of processed data. So we can install our instrument agent on a local computer that is connected to the instrument, but it can be also installed in the network. So the configuration can kept either local or centralized. And the feature set the instrument agent is bringing is folder monitoring. So if there is a new file generated on a computer, it automatically identifies there is something new, and then it takes the file, moves it into the agent. At least this is a copy of the file, so the original file is always kept on the computer. So then data extraction starts, and in the end, we have the full representation in the animal document, which is then sent either to a LIMS or ELN or into our BSSN Hub or SideIML. So for all software or instruments that do not comply yet to 21 CFR 11, we can also offer approval for new versions. So then the user is requested to select a reason and to add a comment. And this is then entered into the audit trail and uploaded together with this information into our solutions. So the file intake can be the animal file together with the raw data set, together maybe with additional file, so PDF reports if you want, or Word documents or Excel files. And we can use therefore a zip format called OPC zip. So this comes from Microsoft. It's also an open zip container format. So if we need to upload more than only one file, we usually use this one. As said, we can do a file output for ELN, LIMS, or SAP. You can apply e-signatures not only once, but multiple times. So this is, to in the end, go to full data integrity. We have audit trails and information about logging. Yeah, so this is how we can really capture these files and bring it into the data lake. And once they arrive, and arriving means, so if we are in a bioprocessing laboratory, if we are in a chemical laboratory, if we are in production, so all those instruments generate a lot of data, and these data are moved automatically into the file store that lives in the cloud. And then we extract metadata and lift it into the metadata store. So what we can do is we can provide to LIMS or ELN solutions. This is shown here on the left side. So with the purple arrows, we can provide access to ELN and LIMS, and they can very nicely extract then the results from the animal files that are living in the data lake. But we can also extract metadata from LIMS or ELN, SAP, compound registration, or inventory management to enrich the metadata layer. You can use then for navigation, not only for queries and searches, but also for navigation. And as already discussed, there are also other data consumers that might have interest in the data that are living now in CSTAR or on in BSSN Hub. So software solutions you are using for visualization, for interpretation, or for artificial intelligence, for machine learning, for design of experiments. So they all can easily access the file store as well as the metadata store and extract the information they need to do their job. So this is basically what is behind this very, very holistic data management system. So just staying on metadata. So what does metadata really mean? So you can think about that we have some metadata that never ever change, like the site, yeah. So the laboratory, the building, maybe even the instrument. So these metadata we call static metadata because usually they stay the same over years. Yeah. So this metadata we can add to any result. And then if the agent is running, it integrates these static metadata already in the first conversion step and brings it into the animal representation. And then there is a service running called Ingress that is doing file ingestion, and then there's a conversion. And then we can also extract metadata from others. Extract metadata directly from the result. Yeah, so we can see, okay, so ChemStation MSD was used and the method was like this and the user was like this and there was a timestamp. And of course, we can move also method details into, so then you can see very transparently what was the setting of the MS and the GC, and the GC, you know, the injector, the oven temperature, the detector settings, everything is very transparently shown. And we can extract all this information and bring it into the metadata layer of the animal file. And then once if the animal file is at rest, so has reached the data lake, then we can go and add other metadata from what we call third-party systems. So what does it mean? So you can think about that a sample itself does only have little information about itself, right? So usually a sample knows only that it comes from LIMS because there is a LIMS ID somewhere in the metadata. It knows, okay, so I was generated on my results were generated on a GC or on a HPLC, and the method was like this, and the user was like this, and it was at that time, and etc., etc. But that's it. So if you want to add context to the sample, so tell, okay, the sample is related to a material, is related to an inspection number, is related to a sample or to a study or to a project or to, as said, to a material, and the material again is connected to a supplier, like we see here for SAP. Yeah, so we know, okay, the supplier is Merck. The inspection lot that was sent was this. So if we connect to inventory management for the same sample, we know, okay, so they use this column. Say they use this solvent. And compound registration, okay, so we see the substances we have in the results are already registered. And we can move all those data, and you can imagine that these are hundreds, even or thousands of different metadata, into the metadata layer and connect it to the information we have from the sample. And then in the end, you can use those master data and contextual metadata to navigate on your transactional data. So if you compare our solution with traditional SDMS that are on the market, so they can only focus on transactional data, so on analytical results, and that's it. So they can do searches and queries, but with our solutions, you can really do navigation. So you can search even, for compounds that exceeded or a certain value or specification, and you can go back, in history, and I mean, you can do a lot of analytical things like predictive analytics, statistics. You can compare the influence of or investigate the influence of, let's say, water quality on results you obtained with mass spec, yeah, and see if there is an interaction between the two. So a lot of things are possible, and remember, so basically the story behind is that today we do not yet even, the question, yeah, we do not yet know questions we want to ask to our data, but once in the future we have a question, we can be sure that the answer is somewhere inside our data. And with our solutions, you can be sure that whatever question you will be asking to your data, you will get the answer. Yeah, so this is basically the story that is all behind. And if you have once done your searches and queries and navigation, yeah, so then you can review again data very transparently. So this is basically the same as we have seen already with SciDiver. So chromatograms from GC, from HPLC, UV-Vis, a lot of different measurement techniques, yeah. They look all the same. And it's really the benefit for you. If you search, you get immediately back the full representation. So you see the signal, you see all the results, and you see all the metadata. So the good way for you and for data scientists to work with your laboratory data in the laboratory of the future. So now, coming back to the question, where is really the adoption? Where is the benefit, yeah, in the end from using standards? So again, think about, we have talked in the very beginning of using open standards for data and also for communication. If we now focus on data, so we have to ask, so how hard is it really to create such a file, to read such a file, yeah, or to store and manage the file, to consume also partially only the file, or verify the correctness, verify the integrity. I mean, for all these questions, animal is always the answer, yeah, because you can easily create the file. You can read it even with your own eyes. So you can store and manage it very nicely with our solutions. And if you have data consumers like LIMS or ELN, they can all read and consume these data files because of the simple structure. Yeah, it's XML. We can verify the correctness of the file because we can apply these e-signatures. also with the integrity of the file. Yeah, so in the end, we have to say, so the animal leverages XML, and XML as such is easy to understand, can be read with any type of software that even does not know, in fact, what animal is in the end. Yeah. And there are really hundreds and thousands of tools and libraries available on the market, yeah, in all relevant languages. And it's also readable for non-laboratory tools, like if you have if you are using for reporting certain tools, like Crystal reports. Yeah, so Crystal reports does not know about laboratories even or analytical data, but it knows how to read a XML file. And you can very quickly start with it. And also developers, yeah, that want to develop new animal converters, they can do it very, very easily. Yeah, and the biggest benefit in the end is that it's long-term readable. Yeah, you can read it over a long period of time, even if we do not have our solutions anymore in 20 years and in 25, 30 years, nobody knows about the future, but you can be sure that animal can be read even until then. Yeah, and if there is no computer anymore, you can print it out on a piece of paper and read it with your own eyes. So in the end, we need to say, yes, we can deliver really on the promise of standards and interoperability. And yes, we can reduce the complexity of instrument interfaces because there's only one single interface for all different type of instruments. Yeah? So if you are using animal, you do not have to think about what kind of instrument interface to develop. Yeah, use always the same. And yes, we can capture the value of a connected lab ecosystem. Yeah, and I mean, we thought that this is a good idea, and also Merck was thinking that it's really an excellent idea. But also Frost and Sullivan was so excited about the techniques we are using, about the solutions we bring to the market for our customers, that they presented to us last year the Technology Innovation Award. And this is not only last year, we will receive the same award again. And think about, there was no other vendor in the last 20, 50 years that received for the second time such an award, and we will get it for the second time this year. So this is a very, very exciting news for us and also for Merck, of course. And a clear signal that using open standards like Animal and CELA and applying solutions that sit on top, like our SciDiver or PSSN Hub or C-STAR Lab Information Hub, is the right thing to do if you want to be ready for the lab of the future. And this is our solutions all about. So thank you so much for your attention, and I am happy to take now questions.
Well, thank you very much, Dr. Peter, for your presentation. Bien, entonces abriremos un espacio de preguntas. Si alguien tiene alguna duda, puede activar su micrófono, puede escribirnos vía chat. Daremos unos minutos para responder algunas preguntas. Ok, no tenemos dudas, tampoco veo en el chat preguntas. Bien. De cualquier manera, les recordamos que estamos disponibles en el stand de Lab Informatics de BSSN. Si ustedes tienen alguna duda o algún cuestionamiento, estamos disponibles ahí todo el día para atender sus inquietudes. Dr. Peter, thank you very much for your presentation. I think we can close today our presentation.
All right.
And we will stay in the booth for any questions or additional doubts. Okay.
Yeah.
Thank you very much and have a good day to everybody. Muchas
Thank
gracias y
you.
buen día a todos.
Bye bye.
Bye bye.